We've learned to evaluate limits numerically by looking at function values near where we're trying to evaluate the limit. We've also learned to evaluate limits graphically by looking at the graph of the image and of the function and determining what's happening. Today we're going to talk about how to evaluate it algebraically or analytically. This is the most common way to evaluate limits, so we're going to look at that today. The first thing I want you to notice is that this first thing that I've got written here, plug in the value and evaluate. That means plug in the number that you're trying to evaluate the limit at. And it's very important that you do that. After we've done 4 or 5 problems, many times students stop doing that and jump immediately down to the third part because that's where the algebra is. Well, if you do that, you're going to make mistakes from time to time and you're going to miss the problem. So, first thing you want to do is just take the number and plug it in. One of 3 things will happen when you plug it in. Either you're going to get a number out, in which case you're finished with the problem. The limit is that number. Second thing that could happen is you get a number on the top and a 0 on the bottom in the case of a fraction. If you get that, then the limit is either infinity or negative infinity, and you're finished. We'll talk about what that means in a later lecture. The third thing, and the most common thing, is that you will get a 0 in the numerator of the fraction and a 0 in the denominator. That means that we can probably find the limit, but we're going to need to do some algebra in order to do that. And the things that we have to do are some of these things that are listed right here. And we'll talk about how to do those. These are just some examples. But anything that you've had to do before, you might need to do with a particular problem. So let's look at this problem here. We're asked to evaluate the limit as x approaches 4 of this particular function. First thing we want to do is put in the number 4. So we're going to put in and get 4 squared minus 5. And that will give us 16 minus 5, which is 11. So we know that our limit is 11. And we would write our answer as the limit as x approaches 4 of x squared minus 5 is 11. This problem, we want to start off the same way. We're going to begin by trying to evaluate the limit by plugging the number in, and if we plug it in, we get 9 plus negative 3 minus 6 in the numerator, and we get negative 3 plus 3 in the denominator. And if we simplify that, we find out that we get 0 over 0. And remember that this is called indeterminate form. That means that the limit probably exists, so we need to do something. So let's go back and let's look at our given function. And what is that function? Or what can we do to that function? When you see it, does anything jump out algebraically that you can do? Well, the numerator can be simplified. So that's what we want to do. We're going to factor the numerator. We keep our limit terminology. It's important that you keep writing this until you've actually plugged in the number and evaluated the function. So now the denominator will not factor. So now we look at the numerator, and how will it factor? X squared plus x minus 6. It's a quadratic, so we try to factor it as 2 parentheses. What will multiply to give us 6? 3 and 2, and the 3 needs to be positive, the 2 negative. So suddenly now we've got a function that we can, or we've simplified it a little bit. And now, hopefully you remember from algebra that if we have common terms, we can cancel them out. So we'll cancel those 2 out. And now we've simplified this down to the limit as x approaches negative 3 of x minus 2. Still keeping the limit terminology. Now, we go back and we start over again. We try to plug the number in and evaluate it. When we plug negative 3 in this time, we get negative 3 minus 2. We get a number out. So then our final answer is negative 5. Notice I didn't write the limit terminology this time. The limit as x approaches to negative 3 because I've actually evaluated the limit at this point and I know what it is. So the limit as x approaches negative 3 of x minus 2 is negative 5.